Hello everyone. Today is day 26 of the challenge. We are just we just have to do five more problems and we are done with it. I'm really excited to I have really good plans on what I'm going to do next. So let's finish this challenge and then I'll speak about what I have to do, what I'm planning to do next through the progress post only. So if you remember yesterday we have implemented a cycle GAN for style transfer where we saw downloaded a training. Let me go to the set here. Downloaded a data set from the Kaggle uh, problem. Here the link is, and the images they look like this. The images of the horses, and then the images of the zebra look like this. Okay, so the why we are using this cycle GAN algorithm, because we believe that when we are going from, let me show you, when we are going from A to B to A, which means when we are converting an image, generating an image uh, from, yes, when we are converting an image from a horse to zebra and then again zebra to horse, we should be able to uh, move back with the least loss. And what this is what it says, and for this we are using two generators and two discriminators, and this is how we are using. If you remember yesterday we have only implemented it, we have not trained it. So today we are going to train it. So I'll say, hey, today we are training the model. uh, it is day 26, and and the statement is this. So let's wait for what the chat GPT has to say. Let's wait. Give me some seconds so that I can move it up here. Okay, let's wait for it to complete the full generation and then we can come back here. Okay, so it says we will implement the training process of the cycle GAN that we implemented yesterday. We will keep the training loop in a normal format, iterating through epochs and batches without using any advanced decorators like the TF dot function that we saw yesterday, keeping it clear and straightforward. So we'll have our own loop iterating through epochs and batches for the training process. So what we will do today, we will just we will continue from day 25. Use the cycle GAN implementation we built yesterday. Uh, okay. So what are we going to do? We will use the cycle GAN implementation that we built yesterday. Good. And then uh, and then we will implement the training loop to train the generators and discriminator. Okay, save intermediate outputs, and then we are going to save the generated images at regular intervals to visualize the process. So we will use, so to summarize, sum it up, we will use yesterday's cycle GAN implementation as model. We will train it using custom our own training loop on the generators and discriminator, and then we will save the generated images. Not every generated or every epoch we are going to save those images. We will save the images at regular intervals to visualize the process. So let's start. So if we'll start with, first we define hyperparameters like the number of epochs, batch size, and learning rates, etc. So we'll do what? We already have imported all these library yesterday, so I'm not going to import it today. Uh, Where are we going to save these images? So let's save the images. So here I'm going to say if set up the directories is to save the generated images. If not, os.path.access. Okay, so in the os.path.access, if this path does not if exist, then create this path. Let's create a path here. Data set and generated images os dot make directory, make editable directory. Oh, make editable directory. Here we generate editable directory, and yes, then let's do what? Let's define the hyper parameters. So epochs, how many epochs we want? 100, thank god. And then let's batch size 16. Let's say batch size one image at a time. Save in interval at 10 interval we are going to see. So label for real and fake images for training discriminators. Label for real and fake images for training discriminator. So we are going hyper parameters. Yes, there was a error typo. So it is going to be real label, and we'll have numpy fill with ones. The size is going to be batch size 16, 16 and 1. So it is going to be a patch can output shape will be 16 by 16 and with one channel. 16 will be of shape 16 by 16 with one channel channel, and then fake label numpy zeros, batch size 16 by 16 and 1. Let's be done with it. Now the step number 2 is we need to define the discriminator loss, training loss, GAN loss, output it, create the fake images, then pass it to the discriminator so that discriminator can differentiate between the real and the fake images. And then once we get the GAN loss and discriminator loss, we will do what? Print it on the terminal, and then we are going to generate the images. So let's read a little. It says the training loop is broken into several steps. Train both discriminator, that is discriminator A and B, using real and fake images. Okay. Then generator update. We will train the generators, which and we have two generators, generator G and generator F, to track the discriminators and ensure cycle consistency. Okay. Um, Visualize and save images at certain intervals to monitor training progress. Okay. So we will visualize and save images at certain intervals. Oh yes, you know what it is. So let's do what? Let's start. For epoch in epoch. What are we going to do? We are going to get the 1,000 images, when we'll call them as real and fake image, real A and real B images. For real A, real B in dataset.zip. I've already imported this. Here we mentioned the train horses. If you remember what we had in the train horses, not here, not here, not here. We have TensorFlow dataset train horses and train zebras. So we are going to zip them, train zebras, horses and zebras, train horses and train zebras, and what I'm going to zip it and take 100 out of them. And then we will do what? Generate fake images using generator. Generate fake. We have the real images, but generate fake images using the generator. So we'll do what? Fake A is going to be generator G dot predict real A. Then we are going to generate fake B using generator F predict real B. Done. Train discriminator with real and fake images. Now we are going to train discriminator with real and fake images. So we are training discriminator A and then B. How are we training? We train on batch. First we train on real image with real label and get the loss. We train on fake image and fake label and then get the loss. And then we average it up. And same we will do with discriminator B. So we'll do train discriminator A. So we'll do discriminator loss real discriminator A real loss. Here we are using discriminator A dot train on batch. Here we are mentioning, what are we mentioning? Real images, real A, and the real label. And then we have discriminator A fake loss, and we have discriminator A train on batch, and then we have fake A fake label, and then we average it up. So a discriminator A loss is going to be 0.5. That is, we are dividing by 0 to 2, and then numpy dot add, not add, DA fake plus DA real. That's DA fake. This is it. Let's calculate for discriminator B. Train discriminator B. So we'll do DB discriminator B. Real loss is going to be discriminator B train on batch. Here we mention real B, real label, and then we mention discriminator B fake loss, discriminator B dot train on batch. We'll say fake B fake label, and then discriminator B loss is going to be, let's average it up. So we'll do numpy dot add discriminator B real loss, discriminator B fake loss. We have got the loss. Now we are going to train generator to full discriminator and maintain cycles consistency. Now we will train what generate GENER generator to full what discriminator and what maintain cycle consistency. So we'll do what we calculated the loss, and we'll do what combined model we had, and we'll train on batch. What are we going to train? Real images, and we pass the input is going to be real images, and using that it is going to generate the fake images and then pass the label. Real label, real label, real A, real B, real A, real B. Why are we doing this? Good question. Let me go and see. We had in the combined model how many? In the combined model we had 6 output. Input A in real images as the input, output 6. So here we are having the validity as the real label and real label, and then we'll pass it for cycle, we'll pass these only, and then for the same A same B we'll pass this only. Now we are going to print the progress. Print the progress. So we'll do what? Print say epoch is epoch plus 1 because it will start with 0. Out of how many epochs? Epochs. And then we'll print what the DA loss is. DA loss, DAB loss is DB loss, okay, and let's print the 0th. This will have the dots, and then print the up to 4 decimal will have dot 4 decimal, dot 4 decimal. And then we'll have GAN loss as G loss, up to 4 decimal. And then what are we going to do? We are simply going to come out. We are simply going to do what? Okay, this should be out of the root. Exactly, we need it, right? So this is going to be out of the print the progress, and then we are going to do what? Save generated images. So we'll do what? Save generated images at regular interval, which is going to be if epoch plus 1, which is 0 plus 1 1, mod save interval is 0. What are we going to do? First we get the fake image, generate the uh, fake image using the generator G, and then fake B will generate images using the generator, using the pass the real image. This will generate fake B, and then we are going to visualize them. So we'll plot a graph of this size, visualize them, generated images. So we'll do what? Visualize. So plot dot plt dot figure, fig size is going to 10 is to 6. Then we'll have subplot. What are we going to do? By 2, we have 2 rows 2 column, and this is going to be the first section. Here we'll plot the title as let me look at it. Original image, generated zebra. Original horse, generated zebra. Original zebra or generated horse, and then we'll show them. Original horse, and then we'll say I am show. We are showing the real image. Real really 0. Why are we doing that? Okay. Okay, we are rescaling back to 0 1. So we are doing what? Rescale to 0 1. And turn the axis off. Axis, we know what axis is, the x dimensions and y dimensions, the number on them. We don't want to see them. And let's do what? Let's have it for the generated. What are we generating? B from this zebra. So it is fake A, really fake B, sorry, fake B. And then we'll have really, and then we'll from the original, and then we have original zebra, then original zebra is real B, and then we have, this is going to be 2 first tile, second tile, third tile, and then we'll have fourth tile. Here we'll say generated from zebra, we are generating horse, so it is going to be fake A, and yes, and then we'll what? Save the image in the directed folder, save figure. So we'll say the name is generated images. What was the name that we are planning with this directory? Generated images, epochs, epoch, say epoch plus for this epoch dot png. I'm just a little confused before I run it. Show. Um, just a second. Okay. So here the thing is going to be generated image. Let's put it in the generated images only, not the data set. Generated images. Generated images. Perfect. Otherwise you would have to change the directory. So let's close it. Let's clear it and see if we have any error. So not this one. Clear it. Yes, let's run it. So Python day 25. So let's run it and see what it is going to generate. So it is training. Let's wait. So what I'll do, I'll pause it and then we can wait. And then we have an error. So the error is at the line number 207, 207, 207, 207. Let's use this. Let's wait like for a couple of minutes, for a minute max, and it will print something. So it has generated the epoch second first epoch completely, and this is how the loss is coming as like this. For all the six outputs, the loss is like this: 1, 2, 3, 5, 6, 7, and let's wait. So it is going to, I guess, do on the 10th epoch. So I'm just going to wait. So it is like it is taking each epoch is taking like a minute. So it will take 10 minutes for to finish 10 epochs. And on the 10th epoch, we'll see an image generated. So what I'll do, I'll pause the video for some time. Okay, so I've generated. So we ran the script. The model was training up to epoch 41. So it has generated for four images, and the images are looking like this. So this is the original horse, and this is the generated horse. This is the original zebra, and this is the generated zebra. So the model uh, has like generated the image really nicely. But I'm going to pass it to the chat GPT to see. Let me compare it from epoch 1 to epoch 40. See, the it is improving. If I would have waited like till uh, let me do what let me wait again and do what let's now print only the first and the 100th. So let's do what, let's not show this on the image. Let's do what, let's not show the image. Let's not show the this thing. Let's just keep on saving the images. So I'll go and run it again. Not here. I'll go and run it again. Go open this terminal here, and then let's keep it running for 100 epochs, and then come back and see how it generates the difference. Okay, I'll pause it again. Okay, so it is done. Now if we go and check the all the images that it has generated, the first ones is like this, and the let's open the fifth one is like this. See the colors, and they this generated zebra and horse are looking better than the this one. See this one, see the difference. And then let's open the 100th one, and let's see, this is more clear. Now let's compare this one and this one. This is more clear. This is the clearest one, right? And this is also clear. So yes, we see that how nicely it has generated. And the the loss of discriminator is very very less. That is why it is clearly generating, classifying, and clearly generating the uh, generated images. So yes, let me go and ask this information, pass this information to ChatGPT. I'll say, hey, this here is the output. This is from epoch 100. Mm, let me pass the images. Maybe I need to not go here. I'll go here and mention it. Not here. Paste it here, and this is the epoch 100 generated image. See, the original horse has clearly defined shapes and feature. The generated zebra stripes are present, but they look blurry. Okay, the stripes are present, but they look blurry and sometimes inconsistent. Hmm. The structure of the horse is still visible, but the is it? I not see. But the zebra features are not well framed. It is a sign that the model is starting to learn the pattern, but it is not effective yet. And maybe that is why the loss is discriminator's loss is not is too less here. So we might have to increase the epochs number from 100 to let's say 200, and then maybe then it will generate the with more clarity. Generated horse is also blurry and lacks sharp edges. Yes. Okay, it says from this to this lacks hmm point point. And here the horses are the shadow of horses, we can see not that much, but yes, it is right, it is saying right. So I guess we might have to increase the epochs from 100 to let's say 200, and then it might perform better. But I'll not do it. It is saying to increase to 500 to 1000, but I'll not do it because it is going to take a lot of time. But I understand what it is doing and how it is doing, and we have understood a lot of things today. So let's do what? Let's add it, add the code, not here, day 25. Let's move day 25 to day 25 to day 25 26 dot p1 and add this and commit day 26, train the uh, CycleGAN and push it to main branch. Let's come here and see, and we see the data here. Yes, yes. So, uh, fun. It was a fun day. We have experimented and learned a lot from what the cycle GAN is and what they do. Basically, what they do. This is more important. Tomorrow we are going to come and learn something new, uh, and hopefully by Friday we'll end the finish the complete the challenge with flying colors. Thank you very much. Now